Hi, my name is Brandon Labonte, and I'm doing my report on my brochure of a pachometer. Pachometer, they are construction's x-ray machine. A pachometer, also spelled Pachometer, or Paco, or Pacho for short, can be the determining machine to see whether or not metal or reinforced steel is within a slab of concrete. Types of pachometers. There's three main types: specialized, analog, and digital. Specialized, it's designed for pinpoint accuracy. It's designed with a smaller body to fit into certain areas, or it's not even meant for concrete. It's meant for welding or epoxy to see if there's any voids. Analog, old school, it has a needle and it has a dial. Shows the readings. It's less expensive than a digital, definitely than a specialized, not as accurate. Digital, most common though. It has an electromagnetic induction that measures and locates the reinforced steel throughout the concrete and can even tell the depth. What does a Paco do? Locates the rebar, measures the concrete, and in some advanced models gives you the rebar size. So, this is supposed to be a breakdown of the components of a pachometer machine. It's supposed to have a little drawing because I couldn't find anything on the actual internet itself. So we have a small rubber mat on the bottom for the panel to glide. We have an electromagnetic sensor used to estimate the size of the steel, the depth sensor used to read the steel depth, sturdy plastic housing for all the mechanics inside, meter, coil, AC adapter for charge, power volume button, back and bottom reading device, front and top of the reading device, basic housing of any kind of mechanical device that would be out in field. As much as it does, it is funny how simple the design actually is, but how powerful it can be as well. And what always throws me is people think that that rubber mat on the bottom is so optional, but until they've tried to use the machine without a rubber mat, it's not. So, let's talk about the function and what it does. So, there are three main parts of a pachometer. The first is going to be the meter, which is going to give you the readings of, number 5 rebar, 8 inches down, or whatever the case is, depending on the engineered details. The second is going to be the depth sensor. Now, the depth sensor is going to be the thing that actually tells you what the depth of the steel is and what the depth of the concrete is. That's going to be able to bounce back all those electromagnetic waves that are bouncing out of that machine into the concrete. And the third, it's like a receiver. So as the pachometer shoots out those electromagnetic induction waves, I'm so sorry, those electromagnetic waves, as it hits the steel takes it and reverberates it back, and there's a little ear inside that housing component of the pachometer that is designed especially to listen for that, so it can tell the tone of it to be able to verify the size. It is incredible. So many times it has saved me from digging through years and decades of old plans. This one's pretty simple. What kind of engineering does it take? What kind of engineering is used to create this device? Well, there's a lot. There's mechanical engineering, because it still runs off power, just like many other things do. There's the electrical engineering. It gives itself its own independent reliability to communicate. There's chemical, because in certain of the specialized ones, like the welding, for example, the welding pachometer machine, there is, I can't remember off the top of hand, I'm not at the shop, but there is a specific amount of mercury that's within those welding pachometer machines that helps to literally scan the welding bead to see if there's any voids or any slag that might have gotten in there from one pass or another. It's pretty incredible. If I had more time, I would love to explain it and really go over the details with all of the instructions. However, I don't. But that's the joy of the pachometer. Is it is a machine that is touched by every engineering field almost, and it's proven. It helps out so much. I mean, especially I'm in California. The fires that happened, the LNU Lightning Complex fires, the Tubbs fires, the Paradise fires, this machine has helped me conduct business and helped me to thankfully give a lot of families some good news and unfortunately some families bad news. Now we come to the best part. Not only because it's the conclusion, but it's the backside of my brochure, and I get to spew a little bit. So, we're going to cover how it works again. It's not magic, it's pure science. Most PACOs operate on the principle of electromagnetic induction, generating small electromagnetic fields, and when those fields find the metal, like I said, it reverberates back and catches onto it. Its sensors detect the changes in the original field it made because of the metal. Strength and nature of these changes tell the PACO how deep and how big it is. The information is later installed, whether it's on a screen or you write down your reports, user's choice. Now, the power of precision. PACOs can prevent costly and dangerous accidents, verify structures and buildings per engineered details, no need for destructive testing like breaking the concrete, ideal for assessing, investigating, and planning construction remodels or issues. In building a stronger tomorrow, this is the tool we need to ensure that there's no issues later.